I want to introduce Jeff Cross, who is, what is it, King of Narwhals?
Yep.
King of Narwhals, all right.
Yep, the narwhals, but yeah.
The Narwhals, thank you. All right, Jeff, thank you.
All right, thank you. All right. Okay, thank you. Thank you, Stephen. I'm going to talk tonight about the crawler, the Googlebot crawler specifically. I am Jeff Cross. Just a note, I'm going to share my slides. I'll give a link later. I'll post a link on the meetup page. I'll tweet it. So there'll be lots of ways you can find the slides. And they'll have links, so you don't need to really write anything down. You can just look at my pretty face. So who am I really quickly? I used to be on the Angular team. Now I'm co-founder at narwhal.io, which is NRWL, not the normal spelling of narwhal. I used to be tech lead of Angular Mobile, and now I'm an Angular consultant, and used to help organize this meetup, and now I am a speaker at this meetup. So everything is full circle. A couple of shameless plugs. That's my company's website. We're doing Angular consulting, keeping pretty busy, helping people get to Angular, just Angular, Angular 2.x plus for clarification. And we also have this cool book, which you can get there, that Victor Safkin and I put together, which is a conceptual and philosophical overview of Angular. Before I get started, I wanted to thank a few people. One, Stephen Fluin for his help allowing me to come speak at this meetup, and also he helped with the content of this talk, as well as Rob Wormald from the Angular team and John Mueller from the search team at Google. Also, big thanks to Alex Eagle, who traveled a great distance to be here. So some disclaimers before I jump in. SEO is a broad topic. It covers lots of things. It's a lot more than crawling. Tonight, I'm going to focus on crawling, though, specifically the Googlebot, how it crawls applications, and specifically how it crawls JavaScript applications. We'll cover general crawling of single-page applications, and then we'll talk a little bit about specific considerations for Angular applications and making them more crawlable. So definition of crawling, if you look at Google, you'll see it's something about babies moving around, trying to figure out how to move. For this talk, when I say crawling, I'm talking about loading, how the crawler loads pages, how it parses them and gets metadata and content from the page, and then how it navigates to other pages. So why is this important? Well, you don't want this to happen in your application if you care about search engine optimizations, where you search for something, you had equity before, you were in the index, and then you're gone. It is pretty costly to fix these issues when if you're in the index, you fall out of it for some reason because your site can't be crawled or whatever other reason. It's a lot more expensive to fix it after the fact, and can take a long time for the crawler to catch up and re-index you, weeks, months, whatever, to get all your pages back in. So it's an important topic to learn before you deploy any new app, whether it's Angular or another JavaScript application, or even if it's not a JavaScript application, to make sure you don't get in that kind of search engine purgatory. So let's start by talking about general best practices for single-page JavaScript applications. There are, in terms of looking at the history of the Googlebot and its ability to crawl JavaScript applications, I break it into three categories. There's the pre-2009, which is the age of server pages. And there's 2009 to 2015, which is the age of aided comprehension. And then 2015 plus, which I call the age of literacy. So looking at the age of server pages, this is what the internet used to look like. You just had pages that the server would return. It's a bunch of links. You click a link, the server returns a new fully rendered page. And things were simple back then. The search engines had a pretty easy time parsing those and indexing. And then we got to this point where JavaScript frameworks started to become more popular, like jQuery, Backbone, some of these early frameworks where people started adding in a little bit more dynamic parts of their applications and eventually started building full applications with JavaScript frameworks. And so Google, looking at this trend, they'd been looking at making the crawler more aware and more able to crawl these pages. And so they introduced a protocol to kind of bridge the gap between what the crawler was capable of then and what would help them get more confidence about the content that was being done, that was being rendered. And so they came up with this protocol, or this proposal for a protocol that had really two parts. One was you have a meta tag that tells the crawler that you're a single page application. And the other part was that you would introduce a way of rendering pages when you would see a query parameter called escaped fragment in the page. So has anyone here used the escape fragment approach on a page before? Okay, wow, not very many. Okay, so escape fragment, we actually have this on the Angular 1 or AngularJS docs site. I know it well because I had to implement it as one of my first projects on the team. So what we see on the left is the normal view if you go to it in your browser. And on the right, we see if we add an escape fragment query parameter, and we can give it the path at the end of it, then we see the same content, but it's not styled, it's just plain HTML. And this is what the crawler would look at, and they would kind of try to render the JavaScript page and take a look at this and figure out what the actual content was based on those two results. But I'm sorry to say that in 2015, the crawler team killed escape fragment. Actually, I'm not sorry to say because it's really nice. The crawler got really smart, and after a while of crawling lots of different JavaScript applications, they decided it was time to start deprecating it and just make your applications more crawlable by doing good things, making fast applications, and that kind of thing. Which brings us to the age of literacy, where the crawlers are smarter. So I'm going to talk about a few things in this new age. A lot of what I'm talking about is ripped from John Mueller's content. He's got a couple of things. He's got a lot of posts around the internet. He posts a lot on Google Plus and different forums for Google Webmaster Tools. He's got this great talk, and I've got the link to this in my slides, from Angular Connect last year that talks about a lot of what I'm going to talk about tonight in some general terms, not in very Angular-specific terms, though. And he's also got a great Google Plus, which I linked to in here from last March, that it's kind of a state of the crawler. Like, here's what you should not do anymore. Here's what you should do. Here are the limitations. I'd encourage you to go read through that and watch the video, and you'll get a pretty good education on the crawler. So some highlights from his post that I want to dive a little bit deeper into today are progressive enhancement, the importance of URLs and links, the Search Console, using correct robots, and being fast. So to dive into progressive enhancement, basically the Googlebot, it doesn't support all the modern browser APIs that we sometimes build our applications for. For example, it doesn't have service worker, fetch, promise, local storage, or request animation frame. Most applications, I think, are polyfilling these, most Angular applications anyway. If you do rely on these, you've got to polyfill, or you've got to have a fallback if your main content depends on these. URLs and links. It should come as no surprise that links and URLs are pretty important for Google. It's the way the index keys every document that it stores. So it's important to have a single canonical URL for identical content. So that's to say, if you have the same page that can be served at different URLs, and that includes query parameters. If you have different configurations of query parameters that can access the same content, you need to tell the browser or tell the crawler that you need to give it a specific link that this page resolves to, that it should be the canonical link when it's referenced. You can do this a couple ways. You can use the link tag with the rel canonical and give it an href of the link that the document should be, or you can use the rel equals canonical HTTP header. Another thing you need to keep in mind is that different variations of content, like internationalization, you should be using different URLs for those, so that it can index the different versions of your page independently. You should avoid hashes in URLs. So this was common a long time ago when push state and new APIs were landing. Google will rarely index content at these URLs now. On-click is bad. It's hard for Google to see it and to know that it indicates a link to content. So if you're using on-click in your applications to navigate around or control interactivity of things that should be indexable, that's bad. You should use a href instead. And a nice thing I'll mention later, but the router, if you're using router link for Angular's router, it automatically creates this for you, so you don't need to worry about that. The Search Console. The Search Console is Google's tool for managing your site's relationship with the Google index, basically. It has lots of tools for looking for errors, for making sure your site is crawlable and correct, and managing sitemaps. The most important tool I'll talk about today is the Fetch as Google tool. This is where you can tell Google, you can ask it to look up your site and then come back and tell you how it saw your site and how it parsed your content. When doing a JavaScript application, you can also ask it to render your page. So rather than just hitting the server and bringing back the response and showing you the source from that, it'll also render your page how it would render your JavaScript application and show you a screenshot of that, so you can see how it looks to the bot and what content it's going to see. The downside of this is you can't see your source code or meta content of the rendered page. So you can't really see the title that it saw. You can't see the meta description or the canonical link. If you want to figure those things out, you kind of have to get tricky and render these things inside of the body of your page so it would show up in the screenshot that you would see. I'm hoping that's something they add as a supported feature soon. This is what it looks like if you look at the rendering version of Fetches Google. It'll show you probably a pretty broken version of your page, how it sees it, but you can at least see that the content is there. So robots. Robots.txt has been around for a long time. It's how you tell crawlers and scrapers what you want them to see and what you don't want them to look at. You need to make sure your robots are configured correctly so that they're not blocking important content, like your JavaScript library. One important thing about this is CDNs or services will often have their own rules about what's getting blocked. So if you're loading Angular or other libraries over a CDN that are important for your content to load, using the Search Console, you can check and make sure that they're not blocking resources that you need and preventing your content from loading. If so, then you should find a new CDN or see if you can configure it so it will allow your scripts to load. And lastly, be fast. So this is one I think people don't give enough credence to, or they don't know the importance of it. But the crawler wants to see your content quickly, and this impacts a lot of things with your search engine optimization effort. The consensus is you should have your content on the screen within about 5 seconds, which is a bad user experience to wait that long anyway. But that's a separate issue. 5 seconds is what most people think the crawler will time out at as it's trying to render your page. So you should audit your bootstrap and render blocking requests. If you're requesting a lot of CSS or scripts, when your page loads that could be blocking other things from doing their work, you should either see if you can remove those or defer them until after your main content's loaded so that you can prioritize the loading of the content you want indexed. This isn't directly related to crawling, but your speed and loading can affect your mobile ranking on Google. Google's published articles saying that they give priority to faster sites because that'll be a nicer experience on mobile. The user's less likely to abandon the site and go back and find another result. They want to serve fast sites to mobile users. So in mobile search, your site gets more preference if it's faster. In addition to that, if you've got a big site with a lot to crawl, the crawler won't usually crawl everything at once. It will usually crawl a little bit at a time, back off for a while, come back again. And that's one, it's got its own resources to think about, but it also wants to be easy on you. It doesn't want to overwhelm your servers with requesting a bunch of pages in quick succession. And so if you ask them to crawl your site, they'll probably crawl it in chunks. And if your site is faster, if it loads faster and it can get a snapshot of your page faster, it can go to the next page more quickly. It can get more sites served in the same amount of time. And it also uses it as a signal to know that your servers are probably capable of serving more pages that it's crawling. So you'll get higher volume of pages crawled. So that's a little bit about general JavaScript application best practices and tools you can use to make the crawler happy. Let's talk about Angular. In general, if you just stay within the bounds of Angular, don't do anything too silly, use best practices, it should just work, kind of. There are a few things you want to get right, though, and a few things that you need to take some care for, which are managing your metadata, doing routing correctly, and building resilient applications. So in terms of metadata, there are really 3 things that are important. The title, keeping that up to date, keeping your meta description set, and setting your canonical links if your application requires setting canonical links. In Angular 4, there's a new service called Meta Service. And there's already in Angular 2, there's a service called Title that make it easy to manage your title and meta tag on the page. And I've got a little example here of how you do it. So you can, in your routes, you can just have something that gets whatever dynamic data you need and then set the title and description imperatively. But with canonical links, there's no API yet to manipulate this inside the browser. You could touch the DOM directly to manipulate. So this is what you have to do right now. Or you could set the link rel canonical on the server when you render the page. And I'll talk a little bit about how the crawler works in a second on why this is okay. The main reason is that Googlebot, I'll dive in a moment a little bit more deeply, but Googlebot, as it's parsing your application, it's not actually clicking links on your page and then reparsing content. Like it's not clicking links within your Angular application. It's parsing your page, grabbing all the links it has, and then scheduling those links to navigate to later. And when it navigates to a link, it basically refreshes the page, does a fresh navigation to a link. And so whatever it sees at that point with the link canonical or description or whatever, that's what it cares about. It's not going to navigate further in your application. So if you're not updating your link rel canonical as your application changes, Googlebot doesn't care. Other crawlers or scrapers maybe care, but as far as Googlebot's concerned, if you, as long as what it grabs as after the first load is correct, then you're fine. But in that case, it's better to use the HTTP response header rel canonical so that you don't have a stale link rel canonical as the user's navigating your application in case there's some other scraper or crawler that is navigating your application that way. Routing. So I just explained this a little bit. When the crawler crawls, it navigates and renders a page, collects the metadata, grabs all URLs, and sometime later, either immediately after this crawl or a day later or whatever, it will navigate to the scheduled URL. And this is not within Angular scope. So the initial navigation is what matters. The first time your router and your whole application bootstraps, puts everything together, that's what the crawler's seeing and cares about. So I've got a couple of suggestions to optimize routing for SEO, for the crawler. Quick redirects and resolvers. So if you've got logic in your, like if you've got a can activate guard in your route configuration, and it's doing logic to check the user's session or permissions to see if they should go to the component they're trying to navigate to or redirect them to another component, you want to make sure that there's a default path that if there's no session or if there's some kind of synchronous data available that you can determine the right path for the user, that you optimize this path so the crawler doesn't get stuck in waiting for you to make network requests and validate user permissions or access and then come back, because there's a chance that the crawler will time out or will have an incomplete render of a page that doesn't have any content on it because it's still waiting for some redirect activity. So a good rule of thumb is don't block on network requests if a crawler is crawling your site and trying to access a route. Resolvers. This one is a little bit more theoretical and something that I think I've seen work with some sites that we've helped people correct. But there's not very good data to back it up other than hunches and anecdotal observations. But when using route resolvers, or when you have routes that require network data to actually populate the content, it's generally a good best practice from user experience perspective and from, I think, search engine perspective to resolve that data or to load that data inside a resolver, which will defer the route from navigating and rendering. And so by doing this, the URL doesn't update until the data is available, and the component doesn't show at all until the component's available. So why I think this is important is because I think the crawler sees this as a signal. Like they see an empty page and they see that there's no real structure of the page yet. I think they look at it as a signal that the content isn't ready. It's not ready to take a snapshot and parse yet. And then once the URL does change and the content of the page gets loaded, then it sees, okay, the DOM now has content there. It's probably got the content I want. I'm going to take a snapshot. I'm going to parse it and then be done with it. Like I said, unverified, little evidence to support, but it's a good practice anyway, so you should go ahead and do it. I don't think it hurts. There are some freebies you get with the router. One is that with the Angular router, it's HTML5 mode by default, which means no hash in the URL. So you've got the good URLs that the crawler likes to see. And router link, as I mentioned earlier, will create crawlable href attributes so that the crawler can, if you're using router link and you've got the paths and everything, you're not directly setting href, but the router handles that for you. Resiliency. So since the crawler, it's not the Chrome you use on your desktop. It's its own browser and it's got its own capabilities. You want to build for the worst case network and browser conditions. You want to make sure you've got good fallbacks. You want to make sure you're not building for something high speed network, high speed computer. You want to build for the worst case scenario. A good tool to measure this is webpagetest.org. And you can see there how long, you can take screenshots of your application and see at what point your content is actually loading, and you also have other metrics you can measure there. to see and make sure that your content's being loaded under 5 seconds. Now, there's a case to be made that you should be loading more quickly than that, especially on cable or on high-speed internet. But for crawler, I think 5 seconds is the general rule of thumb. So here's an example of what web page test looks like. I just did a run on our website. It gives you some numbers about how long it takes to load and render and paint. And you see here, this for our site, this number is important because this is when it's visually complete. So we've got 1.5 seconds, so that's pretty good. So that's kind of all you need to know with Angular. There's more to it, but there are a few other considerations that may be in your mind and are worth mentioning here. And one is pre-rendering. So we've got Universal, which makes it easy to render Angular applications on the server using Node. This is a good thing. If your site, if you've got business that depends on search engine optimization, you definitely should be pre-rendering because as advanced as the crawler is and as easy as it is to make a crawlable site, sometimes things can go wrong. You could maybe push a bad commit that breaks things and you don't notice it for a while until someone from your marketing team comes and says that you've lost all your search traffic and you're not in the index for any pages anymore. In that case, it's nice to have pre-rendering as a backup. So if for whatever reason it's not able to crawl and render your JavaScript application, they can at least see the server responses and see the content that's coming from there, and you'll stay happy and you can make sure your front-end application is fixed at the same time. AMP is another project that a team at Google has been working on for a while, which isn't strictly related to Angular, and it's not even a JavaScript thing because you can't run your own JavaScript in an AMP application. Accelerated mobile pages, if you haven't heard of it, but this is a really restricted way to build applications with their own set of components that they provide. You can do your own styling and things, but you're really limited. But the goal is you build really fast applications because you're so constrained. And you get other benefits, like you get listed in Google's news carousel, which shows up at the top of search. And there's some other places that I think maybe you get listed with it. It's a good thing to look at. It's not necessarily for everybody. I would say if you have a news or content site, it's probably more appealing to you. But I would encourage folks to look at it if you care about search engine optimization and you have a content-heavy site. And here's one I don't hear a lot about from other developers, but there's a specification called JSON-LD to specify structured data in your documents so that the crawler or search engines can display your data in more meaningful ways. It can semantically organize and display things. I think they're constantly adding more ways to show data in structured ways. So this is one more thing you can do that's to specify metadata of pages in the head of your document that is worth looking into. So that's my talk. If you go to this link, I'll be posting this actually right now, just links to a blog article I posted on the same topic today, but I'll be posting links to the slides and some other tools and resources there. All right, thank you.
Thanks, Jeff. So a lot of people have been building Angular applications now for the last few months since we released 2.0.0 back in September. But only now are we starting to see kind of thousands of applications starting to move closer and closer to production or actually being live on the internet. And so I wanted to talk through just very briefly some of the top tips for producing bundles in a very small way, fast way, that are actually going to be delivered via the browser. So to make sure we're all on the same page, I want to start off by talking about what is a bundle. So if anyone has used the Angular CLI, this should look relatively familiar. So this is what happens when you take kind of the hundreds of files that come with Angular, all those node module dependencies, all those third-party libraries and things like that. They all get bundled up into a very small number of HTML, CSS, JavaScript files. So here we actually have just the default CLI project rendering out a vendor file, a styles file, a few polyfills, and then a very, very small main file. So when we talk about bundles, these are what actually end up shipping to your users. And this is actually the most important part because this is the place where the rubber really meets the road in terms of the performance of your application and what code you're shipping down to the user. And so these are actually a very big deal as well because these directly affect the performance of your application. So if anyone has used the Chrome DevTools, this should look relatively familiar. I know it's relatively small, but I'll explain what's going on here. So this is a flame chart of the loading of an Angular CLI application out of the box, right? So if you do production bundling, so you're doing all the minification, you're doing ahead of time compilation, and then the Webpack under the hood of the Angular CLI is spinning out just a few very small bundles, and then you load that application in the browser. This is what actually ends up happening. And so this is the first about 380 milliseconds from when the user hits enter to all those files loading. And then what's all these, at the top you see evaluate script. And so what's actually happening is Angular is not running here. So that's not what's slow about getting bootstrapping a framework. The slowest part about bootstrapping any sort of framework is actually now the size of the files that you're shipping down to the user. And so when you have, whether it's 10 KB or several hundred KB, first the browser has to kind of ingest all those files, resolve all the dependencies, figure out all the namespaces. And that's a more and more complex process the more files you have and the bigger these bundles that we produce are. And so minifying that actually has direct performance implications for your application. So the smaller you can make your bundles, the faster your application is going to load and the better the experience is going to be for all of your users. So one disclaimer throughout this whole talk, I'm going to be using uncompressed file sizes. So if you see something that looks ginormous, like a 423 KB vendor.js file, don't worry as much about that. You should still worry about it, but that actually gzips down to around 96 KB, which is much, much smaller, much faster, even on slower 3G devices. So tip number one, measure your bundles. And so this probably sounds very kind of common sense, but most people don't today have the tooling in place that helps them think about these things. It's kind of interesting. On the Angular team ourselves, we have automated performance and size monitoring. So for example, a commit made it in today that we're going to roll back or fix in some way. Already fixed. So we identified that, hey, we accidentally added file size to the Angular framework, and we were able to automatically identify that because we check these things, because we look at them, we're able to fix that problem. And so if you use the CLI, the best way, or even if you don't use the CLI, the best way to look at this is a tool that is an open source tool called Source Map Explorer. So it's relatively easy to install. You use something called, or just npm install-g source-map-explorer. And then if you're using the CLI, what you need to do is you need to produce a build that includes source maps. So the CLI includes a flag called -sm. So whenever you're doing a build, you can just add -sm, and that will include source maps for you. And obviously, this will work with any other bundling or build tool as long as you can generate source maps. And then what you do is you just call Source Map Explorer, and you pass it the JavaScript that is represented by those source maps. And it will look for those source maps, and then it will use it to produce a graph of what is in that bundle. Another example, so here we say Source Map Explorer dist/vendor star.js, because we don't know what the hash is going to be of that vendor file. But you can also be looking, so that's most of the files in a non-lazy loaded Angular application actually end up in your vendor.js file. But then there's also other files that you can be looking at. So there's always a very small main file, but you can look at, see what that's doing. And then also if you're doing any sort of lazy loaded chunks, which is something I'm going to be talking a lot about, you can look into all of those chunks because they're typically ordered named numerically. So 0.chunk, 1.chunk, 2.chunk, and so on, based on however many chunks Webpack is generating. So this is an example of what that actually looks like. So this is a out-of-the-box CLI project analyzed with Source Map Explorer. And so at the top, you can see the entire framework with all of the configuration, all of the module contents that we've included. It's about 337 KB ungzipped. But then what's really interesting here is you can see the breakdown of what actually contributes to that size. So you see at Angular there in the middle, you've got core, which is relatively small. You've got forms. So by default, Angular CLI is going to include the forms module, which has about 76 KB. But then you've also got things like Platform Browser, which handles all of the rendering out to HTML. But then you've also got the HTTP library, which adds about 22 KB. And so this is all very reasonable. I mean, I think it's all very justifiable because anytime you are looking at the size of a bundle and whether to add or remove something, understanding why it's there and what value it's creating really helps you understand that budget and how to manage that. So I want to contrast this now with another example. And so this is a lazy loaded module that includes Firebase. And so you'll see over there on the left side of things, the biggest part of this bundle is actually the inclusion of Firebase. So Firebase adds about 300 KB. And while I know that they are working on decreasing that size, understanding that that's what happened can help you make smart decisions about how to architect your application. One example of that is maybe you only need that real-time database functionality in some parts of your application, right? Maybe on one half of the app, you can be using HTTP, right? The user-facing part where the data is not changing very frequently. And then you switch into the admin section or any sort of rich content where you want the user understanding what the latest and greatest is. Then you could load that Firebase and pay that kind of bundle size penalty for those features. So this is, once you understand what's going on in your modules, there's a few concrete steps that you can take to actually change how those modules, those bundles get created, and actually decrease the size a huge amount. And so my first recommendation is, when possible, look at deep importing. So taking a library or offering that comes to you and only pulling in part of that library. And I want to give two very specific examples. So Angular, we use a lot of RxJS, and so a lot of Angular developers are using RxJS. And one common thing that I've seen among developers is they just do import RxJS, which is a very nice, very short command, but it actually ends up giving you all of the RxJS objects and all of the RxJS operators, which ends up being kind of a huge change to your bundle size. And I'll demonstrate that in just a second. But it's relatively simple to figure out which parts of RxJS you're using, and then just add in those parts kind of or as needed. So for example, with me, with most of my projects, all I need is observable and then a couple operators. So I'm just going to pull those in directly. And just to visualize, I know this is much too small, but this is actually the RxJS library, which is 187 KB if you pull in the entire thing. So lots of power in RxJS, lots of amazing things it can do in terms of stream processing and observables, but you probably don't need to do all of these things to your observables all on the same page, right? Another example of this is actually our own Angular material library. So this is a component library that we work on that tries to implement the best of the Google material design standards. And so by default, and I actually do this in a lot of demos, I will just pull in the entire material module, which is very convenient, very easy. But instead, you can actually pull in from the subdirectories underneath that at angular/material/toolbar or at angular/material/card. And each of those has a module that you can import directly, and then do the for root and add all those providers manually, or excuse me, in the same way that you do for material module. And when you look at the impact on bundle size for that one, the material library, if you want every single component that we've created, it's about 312 KB. So that is the same size basically as the Angular core and a few of our the other pieces that we've got. So the decision to say, hey, I want all of material, well, that may be the right decision for you. Understand that your users are going to be paying for that a little bit, and maybe you can be more targeted and say, hey, I want a toolbar, I need these sorts of buttons, and I want a tab bar, and I want cards, and maybe I don't need checkboxes or side nav in my application, and then you don't have to pay the performance penalty if you're not importing those pieces. There are lots of other libraries out there. There are more and more every day, and a lot of them have even more components. I think, for example, Prime Faces released Prime NG in the last week with something like 96 different components. So definitely look at how they're bundling those and seeing, hey, is there a way I can just pull in the components I need so that I'm not paying that extra file size? The other thing that's going to end up going on here is tree shaking will definitely help long term. And that's something we're actively working on, so that all of the pieces that you're not using, we want to tree shake out of the application. But if you're building an application today, you still need to worry about these things, and you should still be kind of following tip number one in terms of understanding what's going into your application and why it's going in there. All right, tip number 3, lazy load. How many people here have used Angular's lazy loading or code splitting? Okay, not very many. So I'm actually going to start with a little tutorial. So we all know about the Angular router, or most of us know about the Angular router, where you pass in a initialization using the for root, and then you pass it a set of paths, right, an array of paths. And these paths typically have a path. So what is the URL that we're matching on? And then you're going to pass in either a component or you're going to pass in a list of children. But what you can do is, if you pass a string into load children and don't import these things, and if you pass in the string that's crafted in that way, so it's the path to the module, and then you use pound and then the module name, what the router will actually do is it will lazy load that module only when that route is activated. So in this case, when a user visits this application /admin URL, that's when I'm going to load the admin module and pay all of that extra bundle size if I want to use Material or Firebase for all these interactive things or these visual components. And so it's very, very easy to do lazy loading with Angular because of the work that we've done to make both the router intelligent to lazy load that code, but then also the work that we've done within the CLI and our Webpack plugin in order to automatically code split for you. So we take this router config and we see, hey, you don't actually need the admin module. Let's render that out as a separate chunk. So these are two really cool, really advanced strategies that personally I'm very excited about, and I kind of love and have started using them everywhere, that we try and make easy for you. So now that you know how to lazy load, what do you want to lazy load? So a lot of sites and a lot of content systems have an administrator section. I definitely recommend you lazy load your admin section, because you often need to pull in tools that you don't need to use otherwise. The visitors to your homepage don't need to be modifying your content. They might not need access to some of your services, for example. I also recommend you lazy load your content views. So if you have a homepage that is relatively static or doesn't need a lot of kind of dynamic pieces to it, pull that out and to make it separate for each of your content views. As I said, lazy load your home screen. And at this point, you can actually lazy load everything. So what that means is you can have a root component with routing in it and a router outlet, and then instead of saying, hey, here's some statically loaded modules, and here's some statically loaded routes, you can actually lazy load all of your routes. And what this does is no matter what path a user visits, the loading of that chunk is not going to be in the critical path. And so it actually gives the browser a chance to catch up a little bit, and then it can kind of engage with those additional lazy loaded chunks and load the additional content. So here's an example of an app that I was working on where I had just kind of a wall of routes, and then I had just my admin section lazy loaded. And what I did is basically I pulled out all of those components into a main module, which you just basically update the two ng module definitions. So it's relatively straightforward. And then I changed it to path, empty quotes, load children, and then I pointed at that main module. So this one change had a huge impact on performance, because now the user doesn't have to load that until they get to that route. The last tip here for everyone is ahead of time compiling. If you're not already ahead of time compiling, or if you're running into issues with ahead of time compilation, definitely let me or someone on the team know, because this is a really core strategy for producing fast, small bundles and for using Angular really successfully at scale. So this is an example of that same source map. This is our compiler. So our compiler itself is about 400 KB ungzipped. So that's actually very big. So if you're using just in time, which means that you're doing all of your compilation in the browser, not only are you paying a performance penalty to do that compilation in the browser, but you're also paying to download the entire compiler. And so when you switch to AOT, what happens is at build time, we take all of your templates and all of your components and we turn them into ng factories, and then we don't actually ship the compiler anymore. And so if we talk about what you're actually giving up, you're giving up that 408 KB of compiler, and then what you're going to see in your source maps is actually just the generated code. So this is just the VM optimized JavaScript that is modifying and updating the DOM with all your changes. And so you can see here that, for example, there was a schedule grid component. It's now become a schedule grid component.ng factory. And so these can be a little bit bigger, but we are working to make them smaller, and we feel like we have a very good solution to swap these out and possibly see even 5x improvement in terms of their size. So brief summary of the strategies we've talked about. So first and foremost, measure everything you do, because that's how you're going to know what goes into your applications and how to make them better. Deep import when possible. So don't pull in the 96 components from a third-party library if you can help it. Lazy load all your components, and the finer you can segment your, lazy load your modules, and the finer you can segment your modules, the better. And then lastly, make sure you're AOTing to get the smallest bundles you can. Thank you so much. All right, and then next up we have Sashko, who is from the Meteor/Apollo team, and he's going to talk to us a little bit about what they're doing and how Apollo can help.
I thought my talk would fit really nicely into the theme of tonight, one of which was about search crawling, the other one is about making your bundle smaller. And I want to talk about these things in the context of data loading, right? So, what are some of the greatest things about Angular? For me, the thing that I enjoy the most compared to other frameworks that might be out there are things about helping you build your app, right? So you can make your app structure really modular and lazy load different modules. you can have declarative UI development. So it's not just you're developing components, but you can use a declarative template language that lets you write your code easily. Your code is statically analyzable, and you can use stuff like AOT compilation to get better performance without putting in any extra effort. So let's dig into what this stuff actually means, because I'm going to have to call back these concepts later in the context of data loading. So for templates, having a declarative UI means that rather than using a fully featured programming language to develop kind of the views in your app, you can use a templating language which is optimized specifically for designing these views. And that means the framework can understand a lot more about what you're trying to do with that view. Rather than ending up with a lot of DOM nodes, it can know that you're iterating over something, or that you're trying to inject some data here, and be more efficient in a lot of different ways. How about static analysis? So the first thing is that Angular recommends TypeScript, which lets you statically analyze your code to make sure that all the types are matching up and you didn't make any silly mistakes, especially as you're editing your code and your app is getting larger. You can validate the templates that I was talking about before across your whole app using some of these language services that are built specifically for Angular templates, and even validate the types in your templates with the types in your code, so you can make sure that everything in your app bundle is going to work together well. And lastly, like Steven mentioned, ahead of time compilation takes all these great benefits and puts them together so that you can get better performance out of the box, taking advantage of all of this code analysis to eliminate code you're not using, get better runtime performance by not having to load all these various parsers and compilers, and even inline stuff like CSS so that you don't have to make extra requests that you would have to make otherwise. So I think these are some of the best things about having a framework that's kind of highly cohesive and optimized around the build tool, around the templates, around the router, all of that stuff. But what about data loading, right? So our app bundle is super happy. We have, as denoted by the heart here, we have your Angular templates, you have your TypeScript code, everything's working together, it's being checked for correctness. When you're writing that code, it's really happy. But what about when you're loading your data, right? Does your server get to join in all this fun of validating that your code is correct and performant? So what do we need? Well, I think we need the same stuff that we just talked about for your UI code, but for data loading, right? It needs to be declarative so that your tools can analyze it and understand what you're trying to do. It needs to be statically analyzable, so you can analyze the stuff and make sure it's going to work across client and server. You might even want something like ahead of time compilation, right? What if you could look at your app, identify what data it's going to load, and pre-compute a lot of the stuff that you were going to do at runtime, instead of having to boot up a whole data loading system just to get some bits of JSON. How could we get that? Well, plot twist. So this talk is actually about GraphQL. So GraphQL is exactly a data loading system with the properties that I was talking about before. So you can think of it as very similar to a REST API in the sense that it's a stateless API. You load your data over HTTP most of the time. You get JSON back from your server. But instead of having a list of endpoints, you define a schema for your data. So just like you have a type system on the client with TypeScript, you define a schema for your API. So on the leftmost side of this slide, you see some types defined in this kind of GraphQL schema definition language. The thing in the middle is a GraphQL query, and that's the thing you use to retrieve the data from that schema, right? So you can see with the query, we start with a particular post in our API. We can get the title, we can get the votes. Then we can traverse from that onto a different resource, which is the author of the post, and get some fields on that. So not only do you have a schema that tells you what kinds of data you can get from your API, you can filter down the fields that you want and load related resources together. And finally, on the right is what the result might look like for a query like that. And it's really nice because it's very predictable. You can look at the query and know exactly what fields you're going to end up with. And the best part is that your developer tools can do the same thing. So what does it look like to use GraphQL with Angular, right? We're here at the Angular meetup, and well, it's very important to know. So on the left is an Angular template. And like I said, I think GraphQL is kind of like a template for your data loading. So the same way you have a template string that you might associate with your component, you have a GraphQL string, which is like your template, but for the data. So you can see that on the left, we're using a field called posts that we're iterating over. And on the right, in our query, we have the same field posts. So if we put these two things next to each other in the one file, we can be sure that we're loading the data that we're actually going to use. And you guys might have heard this before in the context of Angular templates, but are they magic strings, right? We're writing our TypeScript code, and that's great. but we have this multi-line string in our app. So what do we do with that? Well, it turns out that just like Angular templates are not magic strings, they can be precompiled and analyzed. GraphQL queries are not magic strings because they can also do all the same things. So for example, this is a really simple example of an ESLint plugin that we wrote for GraphQL that lets you put in your server-side schema and get type checking against the query strings that you have in your client, right? So not only now are you getting type checking with your UI code and your TypeScript, you're getting the type checking of that query against your server. So now we're part of the way there, but we're not the entire way there, right? We have those two things together, but we haven't made the final connection. And that's where code generation comes in, right? So just like Angular templates can be converted into TypeScript code or compiled ahead of time, you can do the same thing with your queries as well. So you can get a specific query that you want to use to load data for part of your UI, and you can compile that into a specific set of TypeScript interfaces. So that means that not only are you getting the schema for your server, which might have all kinds of different types and a bunch of different fields, but you're getting the schema and the types specifically for that one query you attach to that one component. And what that means now is between your GraphQL query, between your template, and between the controller code of that component, you can now validate that everything's working together well, that you loaded all the data that you need to display in your template. So now we've completed the chain, and now we can be super happy that all the stuff that we get to validate across our entire client-side code base, we can now use a very similar set of tools to validate across between our API code and our data loading queries, and between those queries and the client-side code itself. And AOT is also very trendy, so we must have that here as well. And there's a lot of great things you can do even with data loading with ahead-of-time compilation, right? Can you make your app just more efficient, basically for free? And you can, because just like that ESLint plugin can identify where you have a GraphQL string, it can pull that string out, treat it as a query, and save it. So first of all, you can pre-parse it, so you don't have to do anything about parsing queries at runtime. But more than that, you can actually avoid sending the query in the first place. So just like you can avoid sending your Angular template and you can just send the code that you need, you can actually just send a query ID to your server, which will have that query precompiled. And you can do stuff like start loading queries for the data for your UI before your front end has even booted up. So the first thing you can do as soon as you get that route, you don't have to even load your UI component to know what query it's going to ask for. You can precompile that directly into your application. So that's kind of a cutting edge thing. Actually, the second package about preloading those queries is something we actually published this morning. So we're really on the cutting edge here. So I think basically my main point here is if you like the way that Angular templates work and you like the way that you can check all of your code, you can get all the same things now for your data loading. You can get the modular app structure where every component specifies its own data requirements. You can have it be declarative. Instead of having to query multiple endpoints one after the other to compose some data, you just specify nicely in one query. Your code is still statically analyzable because there's all these tools that consume your GraphQL queries and interact with the rest of your UI code. And you can even compile it ahead of time for performance like you want to do with the rest of your GraphQL app. And there's still a lot to do. So all the tools that I showed you are tools that exist. There isn't something that is as nice as the Angular CLI that puts them all together into one box. So you can't run the Apollo Angular command that will precompile everything and validate everything all at the same time. But we're getting there. All these tools are things you can use today. And it would be cool to go even further. And just like there's a language service for your templates that you can use to maybe get auto-completion or validation directly in your editor, people are working on the same thing for GraphQL. And one thing that could be really space age and get your imagination going if you're really into templates and data loading like I am, would be even generating your data loading code from your templates directly. So you're writing your template, you're iterating over a field, and you ask for some subfields on that. You could easily compile that into a GraphQL query and not even have to write data loading code at all anymore. So if this sounds interesting to you, Angular and GraphQL are something that I think could be really exciting, but not everyone's using it yet. So I encourage you to go and learn more. Learn more on graphql.org, which is the main website for the GraphQL technology for data loading. And also, Apollo is the team that I work on, and we're working on tools that help people take advantage of GraphQL. So combine your GraphQL API with your Angular app and get all those developer tools that I was talking about before. So you can also check out our website at apollodata.com. And lastly, we're hiring. So if this stuff is exciting to you, you can also hit me up for a job. So thank you.
So all right, we're inviting Jeff back up to the stage, and now we just want to do some short Q&A, or as long as you guys want, and then we will move over into Angular team office hours, so people just help each other as part of our community. So questions?
I have a question about microdata or micro formats, which used to be a thing in the past. Is that still a thing, or should we be using it, not using it?
I really couldn't say. Ask John Mueller.
Okay, because you mentioned the JSON.
JSON LD is the hot new thing of.
So is that like the next
Google's
version?
embracing it. It seems that way.
Okay. And just one more thing about the polyfills. Do we know what are we targeting, or we don't know at all? Like if I'm building an application that targets just the latest Chrome and Firefox, and I don't care about polyfills, but I want it to be crawled by Google.
Yeah, the 5 that he's pointed out, that John's pointed out, are service worker, fetch, local storage, request animation frame, and promise. There might be more than that. You could
that do exist or don't exist?
That are not available. You could probably reverse engineer that to what version of Chrome they maybe, or what fork or whatever they might be using, and then see what else is missing that you would expect.
Okay, thanks.
You mentioned earlier uninstalling Angular-CLI and then installing @Angular-CLI. Are all the options still the same for NG? Nothing's changed, right?
Yes, it is 100% the same tool.
Good.
All of the same options. New package name.
Any new files?
New files. What do you mean by that? In the blueprints?
When you create a ng new and so forth, will there be?
So every version of the CLI that we release might have small changes to the configurations and things like that. If you look in the Angular CLI README, it's got an upgrading document, which I believe you just type right now as a beta 30, you type ng upgrade, I believe. And what it will do is it will actually generate a new project or compare every file in your project to the current blueprint. We just introduced that very recently in one of the latest betas as an experiment. We're not sure if we're going to keep that yet. But as of right now, you can use that to make sure that you're staying up to date with the latest CLI.
The other thing, I'm a little bit fuzzy. I think I read that the Angular CLI doesn't work with AOT. Is that correct?
The Angular CLI absolutely works with AOT, and in my opinion, it's one of the easiest ways to take advantage of AOT.
So,
we believe in it so strongly that we, as of one of the last 2 betas, actually made it the default for all production builds. So if you're using the Angular CLI and you do ng build -- prod, that will be doing automatically an AOT build.
thank you.
Other questions? I think there's one right there, Christina, or whoever's the mic.
Why did you do that? Why did you change the name on the npm install to @?
So npm has this feature called scopes, which basically say that all of these npm packages belong to the same organization. And so they have the same authorship, the same level of trust. So you know that it's coming from us rather than coming from just someone in the community. Whereas when we originally built the Angular-CLI, we built it outside of that scope because it was more of a grassroots kind of community project. But now we've brought it fully into the Angular organization because this is a thing that we believe in and we're supporting and maintaining long term. Does that answer the question?
And you couldn't do that with the old Angular so that there wouldn't be so many names. You just polluted the namespace. Thank you.
Yeah, but I think the goal is that we really do want you to know where the packages that you're using and the tools you're using come from. Because with coming from the Angular team, that means that it's kind of validated and used at scale within Google. Google is kind of an implication for all those things. We did a very similar thing with Angular Universal, where that was a community project, but now we're taking over more of a leadership role with that. And so you saw the same thing in GitHub where we pulled in Angular Universal into our repositories and into our organization. Another question back there? Brad's got it.
This is another one of my fuzzy memory questions. ng content, ng container, those are fully supported or will be? I mean, they're not experimental, right?
Igor?
Why me? They are fully supported. I don't know if they are marked as at stable or at experimental.
Okay.
I don't know right now. We can look it up. Yeah. But even experimental means we commit to not making breaking changes. The difference is that if there's need to evolve the API, the deprecation policy is slightly different.